Hi, welcome back to our video. We are still here in the fundamentals of conduction. So aside from the classification of heat conduction problem, we also need to discuss what we call the thermal properties. Okay, so in this section, we will discuss some of the thermal properties in the heat conduction equations. Under these thermal properties, we have what we call the thermal conductivities, and we also have an introduction regarding this last time, and we have also the thermal diffusivity. So based from our previous topics, we have learned that the rate at which heat is transferred depends on the property which is called the thermal conductivity, or we barely know this as our symbol or letter K. So let me have this specific section, the thermal conductivity, or our letter K. Okay. And in our previous computations, we have used this thermal conductivity as, we have used this property as what? As constant, right? So we treat this property, specifically the thermal conductivity K, as constant. Once again, based from our previous topics, we say that this the rate of heat transfer depends on the property of this material, which is what we call the thermal conductivity, right? So every material has its own thermal conductivity, and the value of this Q, the rate of the heat transfer, depends on the thermal conductivity of the material. And once again, always last time we treat this thermal conductivity as constant. So based from our Fourier's law, the thermal conductivity associated with conduction is defined by K is equal to our heat flux divided by the oops, what happened to my, sorry, okay. So instead, let me rewrite our Fourier's law. So based from our Fourier's law, we say that our Q is equal to Ka, our temperature gradient, and our change in X. Okay, and if we can have our rate, so our per unit area, so we have K partial derivative of t with respect to x. So we have this. So based from this Fourier's law, we can now have the definition of our K, wherein our K is our heat flux divided by this part here, right? So this is now our thermal conductivity, which is associated with conduction heat transfer. So based from this, as you can see, it follows that for a prescribed temperature gradient, so for this prescribed temperature gradient, the heat flux, our heat flux, increases with increasing thermal conductivity K. Okay, based from this foregoing equation. So in general, the thermal conductivity is not constant. So last time we treat this as constant, but generally speaking, the thermal conductivity is not constant. So I have here, I will show you some figure or illustration showing the different thermal conductivity of the material with a certain temperature. So say this x-axis here is our temperature, Kelvin, and so this K here is the unit of our temperature, which is in Kelvin. So say we have 200, 4, 6, 8,000, 1, 2. Okay. So based from literatures, this y-axis here is our thermal conductivity K. That is in watts per mK. Okay. So based from literatures, I have here, for example, the thermal conductivity of of steam, looks like this, and the thermal conductivity of air is looks like this. So this is air, this is steam. Okay, so by the way, the value of this K is about 0.001. This part here, excuse me, 0.1, then 1, then 100. So okay, so as you can see here, the as the temperature varies, the thermal conductivity of, say, our material is air, then as you can see, the thermal conductivity varies with different temperature as well as the steam. Okay, how about say, by the way, this is an example of fluid, and so let me have some illustrations of our solid materials. Say, sorry. So based from my research, the thermal this is the thermal conductivity of iron. So this is a solid material. So the property of this iron, as you can see, with respect to temperature K, the thermal conductivity, the value of the thermal conductivity also varies with the temperature. Okay, across the range of this temperature. Okay. Let me have another illustration using what material? Say stainless steel. So it looks like this. Sorry. Yeah, it looks like this. So this is the stainless steel. Okay. Okay. So you can search for the certain graph of the different materials across the range of temperature. So you can search for the values of their thermal conductivity. But the main point here is that the thermal conductivity of the material is not constant, and it varies across the range of temperature, whether it is a fluid or it is a solid. Say we have for example, we have a certain condition wherein we have a normal temperature and pressure. Then the value of our thermal conductivity, the value of our K, is fixed and can be found on tables. So that is for a certain or for normal temperature and pressure condition. Okay, so that's why we can use a certain constant K. Okay, for temperatures and pressures beyond, the thermal conductivity is a function of temperature and an average value for K.